Today we are going to graph polynomial functions. So we can see here that we're given a function f of x equals x plus 2 times x minus 1. And we have this graph over here that we want to plot on. All right? Reminder that our x-axis is our horizontal axis and our y-axis is our vertical axis. So we're going to start off by using our knowledge of zeros to plot the first couple of points. All right, so if we look here, and we look at this first factor here, x plus 2, we can make this whole factor 0 by setting x plus 2 equal to 0, okay, which gives us a 0 at x equals negative 2. And we can similarly find a 0 at the second factor by setting x minus 1 equal to 0. Okay, and that'll make a 0 at x equals 1. Now let's remember our zeros, they are what shows up on our x-axis. These are 2 points that show up on our x-axis. So once we find our zeros, we can actually just plot those. If I go to x equals negative 2, I'll have a point right here on my graph. If I go to x equals 1, we'll have a point right here. Now, obviously our graph is going to be more than just 2 dots. So we're going to start evaluating this function, this f of x equals x plus 2 times x minus 1, in order to kind of sketch out and estimate the rest of our graph. So the next spot we should look at, and I'll draw kind of a blue line here to separate our work here. We found the zeros in red. Now we're going to find a point that lies in between these 2 red dots. And so if I look in between negative 2 and 1, okay, I can choose between the point at x equals negative 1 or at x equals 0. Either of those will work, but let's evaluate at x equals 0, just because 0 is a nice clean number for us to work with. So at x equals 0, if I plug that into my function, f of 0 equals, we'll get 0 plus 2 times 0 minus 1. Okay, we'll get a value of, we'll have 2, I'll get rid of this sign here. We'll have 2 times negative 1, which gives me negative 2. So our point there that we're going to plot is going to be 0. That's where our x was, right? 0, comma, negative 2. So I go to that, I go to my graph, I go to x equals 0, which is right on the vertical axis, and I go down 2 points, and we will have a point there in blue that represents that kind of in-between point. All right, so that tells us the behavior in between those dots, and we can start kind of sketching roughly what we think our graph might look like in between those dots there. Okay, it'll kind of have a U shape. Because remember, polynomials will have nice smooth curves. Okay, and then I'm going to draw another line because now we want to figure out what's happening outside of our zeros, outside of our red lines. All right, so we're going to kind of similarly pick 2 different points on either side of those red points. So our furthest left 0 is at x equals negative 2. So let's slide out to x equals negative 3 to find this value on the left and see where our graph goes. So at x equals negative 3, okay, I'll get f at negative 3 equals, we'll have negative 3 plus 2 times negative 3 minus 1. And if I go ahead and calculate all that out, okay, negative 3 plus 2 will give me negative 1, and negative 3 minus 1 will give me negative 4. So we'll have a positive 4, because a negative times a negative will be a positive. If you need more work with evaluating the functions, please look at yesterday's video from 1031. Okay, so that will give us a point at -3 for our x and 4 for our y. And let's go ahead and plot that. We go out to -3, 2, 3, 4. So we'll have a point right here. Okay, and let's pick a point to the right of our furthest zero. So our 0 is at 1 here. So let's go to x equals 2 for our next 0. X equals 2. So we'll have the function at 2 equals 2 plus 2 times 2 minus 1. And so that will equal 2 plus 2 is 4 times 2 minus 1 is 1. So 4 times 1 will just give us 4 on this side. So we'll go over to x equals 2. We'll go up 4. And that's where our point hits. So then we can kind of sketch in the rest of this graph. Right? And it's not going to be perfect, right? We're making a sketch of this. But we can see that we're starting to get that nice U shape that polynomials have. Now, to kind of close this out, we do know that this graph is going to go on forever, however. I could keep picking different values of x, let's say x equals 10, and I could still get some numbers. So if we were to try that out and plug 10 into our original function, okay, we'd get 10 plus 2 is 12, times 10 minus 1 is 9. So we'd get some high number. I think it would be 108 is what we'd get if we plug that in. Okay, so we're way off our graph at that point. So we know that we're going to go on forever in the positive direction as our x increases. Okay, and the way we represent forever on a graph is with an arrow. And the same thing would happen on the other side, right? We could continue selecting values for x that got increasingly more negative, okay, and our y value, or our function value, would continue to increase. So we will go on forever on the left-hand side as well. Then you can see that we get a really nice U shape that matches kind of what we've seen. Obviously, it's a little squiggly with me drawing with my computer mouse, but yeah, that's a pretty good estimation of what our graph looks like. All right, so here are the formal steps for what we're doing when we are plotting graphs. And I want you guys to copy this down to the back side of your note sheet. First thing we're going to do is we're going to find and plot those zeros. And remember, those are our x-intercepts. Then after that, we're going to evaluate the function in between the zeros and figure out what is happening in between those points. Then we need to pick 2 points outside of the zeros to plot them. And it's important to note in step 2, as you'll see in the next example, that we might have multiple points in between our zeros. If we have 4 zeros, we're going to have 3 different points in between them that we need to plot. So we are not going to do this next example in the video, but if you are watching this, please complete this to finish out your notes and try this on your own for comparison purposes. And just notice that, hey, we have 3 different factors here in our equation. So we're going to have 3 different zeros. We're going to need to find 2 points in between those zeros in order to accurately sketch this graph.